In today's class and video, we are going to look at the basic principles of column chromatography. So we'll start our introduction by looking at the setup over here that shows or explains the various steps or stages in the column chromatography process. So from the setup, the figure A here shows how the test sample is loaded onto the surface of the stationary phase in the glass column in the column chromatography process. The figure B explains how the various components of the test sample separate as they move through the stationary phase in the column. The figure C here explains how the separated components of the test sample interact with the stationary phase as they travel through the column, with the separated components with the green resolve band as shown over here having a weaker interaction or a weaker adsorption or affinity for the stationary phase, and therefore travels at a faster rate through the column to its outlet and elute first. On the other hand, the separated components of the mixture with the orange band as shown over here has a stronger interaction or adsorption or affinity for the stationary phase and will travel more slowly through the column and elute last as compared to the green band that has a weaker interaction with the stationary phase. The figure D and E over here also shows how the separated component of the test mixtures elute through the column outlet and are collected as fractions in test sample, with the green resolve band eluting first and collected as a fraction as shown in figure D over here, followed by the orange resolve band eluting last and also collected as fraction as shown in figure E over here. So for the basic principle in column chromatography, what you have to note is that column chromatography uses an analyte which is loaded over the silica beads packed into a glass column. And here, the silica acts as a stationary phase, and the solvent, which is the mobile phase, is allowed to flow through the silica bed under gravity. And one thing that we have to note is that the different components of the analytes exhibit varying degrees of adhesion or adsorption as a result of their polarity to the silica, which is the stationary phase. And as a result, they travel at different speeds through the stationary phase as the solvent flow through it, as shown in this chromatographic process over here. Also, the components that adsorbed more strongly to the stationary phase travel more slowly and reaches the column outlet last as compared to those with a weaker adhesion or adsorption to the stationary phase. And once the mobile phase comes out of the column, it is collected in small fractions as shown from this picture over here in a test tube. Let's now look at how the compound polarity affects our result in column chromatography. So I will explain this by using this picture or diagram or setup over here. So from this setup, so we can see this is our glass column over here, and this is our silica gel, which is a polar material and which is used as a stationary phase over here. And these are the various compounds separated from our sample solution during the chromatography process. So we have compound A, compound B, and compound C, with compound A being the most adsorbed compound onto the stationary phase, which is the silica gel, followed by compound B, and compound C being the least adsorbed compound onto the stationary phase and hence will elute first as shown in the picture over here. So in terms of their polarity, the compound A, which is most adsorbed to the stationary phase, or that has a higher affinity for the stationary phase, which is a polar material, is is more polar than the compound B, and the compound B is also more polar than the compound C. And also, a more accurate version of the column chromatography is the HPLC, which stands for high pressure liquid chromatography or high performance liquid chromatography. And the HPLC uses a pump to force the solvent through the column at high pressure. And this is particularly used for mixtures containing very small particles, which have a higher resistance to the mobile phase flow. So now let's look at the advantages and the disadvantages of the column chromatography. And we'll start by looking at the advantages. So one, all different kinds of complex mixtures can be separated by column chromatography. And two, separated components retain their properties during separation and after separation. And three, there is no limit for quantity as any amount of mixture can be separated by this technique. And four, the separated analyzed can be reused. And five, this process can be automated. So the disadvantages, it's time consuming process for the separation of compound, and two, it's expensive as higher quantities of solvents are required, and for the automated process is complicated and costly. So these are few of the disadvantages of the column chromatography.